All right, it looks like the filtering in is slowing down a little bit. So we're going to go ahead and get started here. It's 1:02. I wanted to thank everyone for joining us today. This is Shore Friendly Kitsap's first ever online webinar series, and we're really excited to be here. I'm Angie. I run the communications for Shore Friendly Kitsap, and I'm really looking forward to our time together today. We have a great turnout, and we have a couple of great guest speakers, and I'm really excited that we're all going to be learning more about coastal processes in the Puget Sound. So first up for our speakers, we have Jim Johannessen. If you want to raise your hand, Jim, you can kind of wave. And he is the principal geologist of Coastal Geologic Services. CGS was started in 1993, and Jim has performed hundreds of coastal assessments through the Puget Sound region. In addition to that, he has run numerous coastal engineering design and design restoration projects. Our second speaker today is going to be Jesse Adams from Kitsap Conservation District. All right, awesome. Thanks, Jesse. Jesse is a resource planner at KCD with the Backyard Habitat Program. He specializes in riparian planting and noxious weed management and has restored an average of 13 acres of stream habitat a year, which is pretty cool. All right, we're super excited to have both these speakers here to share their expertise with us. But before we get started, I would like to introduce a very important person, Christina Korecki. She is the program manager for Shore Friendly Kitsap, and I'm going to give her a minute to share a bit about what we do and why we're hosting this webinar series.
Thank you, Angie. So hi, everyone. We're super excited to have such a good turnout today. Again, my name is Christina Korecki. I'm the program coordinator for Shore Friendly Kitsap, and I've been with the county for over 10 years, but working directly with Shore Friendly Kitsap for the last 6 and been with it since the beginning. The program is sponsored by Kitsap County, but is funded by the State Estuary Salmon and Restoration Program. And so we, a big shout out to ESRP. We are really thankful for their support and funding to do this meaningful work. A quick plug for Shore Friendly Kitsap, for those of you who aren't familiar, it is geared towards shoreline landowners. And our goal is really to empower people to consider natural shorelines and alternatives to bulkheads for their properties. So the big picture idea and goal is to improve the health of Puget Sound, and increase awareness of shoreline restoration opportunities for private properties. So we help landowners with their bulkhead removal and soft shore restoration projects. And we have a number of incentives and services to help folks kind of get through the process and for their projects to be successful. So today we're really happy to be able to provide our first ever webinar series, and we're hoping this information is very helpful for landowners and really anyone who's interested in learning more about coastal living. Today's webinar will focus on coastal processes and better understanding the dynamics of shorelines and beaches, and it will also touch on vegetation management. So with that, thank you, and I'll hand it back to Angie.
Awesome. Thanks, Christina. All right, so we're about to get ready here, but I just wanted to run through a few housekeeping items with all of you guys today. I'm sure at this point you guys have been through several Zoom webinar meetings, but just in case, because this is a Zoom webinar, that means you'll not be able to see other participants. Other participants can't see you, and you will not be able to use your audio or video. What you can do is communicate with panelist speakers, and we have 2 options for that. So we have the chat option, and so Christina is going to be manning that. So if you have shore-friendly questions, restoration questions, some general like shore-friendly information, go ahead and send that her way, and she can take care of that for you. She'll respond via the chat. We also have the Q&A down, so that'll be down at the bottom bar, and you can use that, and that'll be I will be managing that, and that is going to be directed for our speakers. So if you have a question during the actual presentation, go ahead and shoot a message over to me, and we can handle that. There will be an intermission time. We'll also have time at the end, and if it's a super important, like pertinent question, I can interject when appropriate, and we can get that taken care of for you. So those are the options we have today, and last but not least, this is being recorded, so just so you guys are all aware. And we should be good to go. Okay, I'm going to hand this over to Jim. Take it away.
Get that. I'm going to get the share going here. Okay. Okay, is that first slide coming through?
Let's see. Yep.
Okay, great. Well, yeah, again, that's wonderful having everybody here. I hear we have about 100 folks at the limit and turned a few away. I'm going to run through, as Angie said, and as Christina said, and the coastal processes. I'm going to start with bluffs and geology, and then talk about the beaches and the coasts, coastal systems, and then we'll take a short break for a few questions on that part. And that's about more than halfway through. And after that, run through and talk a little bit about habitats and drainage management in particular at the end. By way of introduction, beyond what you heard, I grew up just about living on the coast, just back from the coast, spent summers on the water my entire life, screwing around in boats and things. And I've been watching, beaches change for all these years, and body surfing, doing all kinds of things in the water. Studied this through to a master's. I've got an engineering geology license in the state as well. But when I started my business almost 30 years ago, I started working for coastal landowners, and including in Kitsap and Bainbridge and all other places around. So I know, I've worked on hundreds and hundreds of these sites, so I know the issues, and hopefully I can cover the processes first, and then we'll get to some of the implications at the end. And then next time on the next webinar, we're really talking directly on management. So I'm not going to have all the answers on bulkheads and soft shore today. That'll be next time. So again, the system is composed of many parts. The bluffs provide the primary sediment for the beaches. The beaches provide protection to the bluffs in most cases, and provide all the habitats that our salmon and other species use, provide habitats for us, for many things that we do as well. So it's a cycle of us managing and sometimes not being able to manage, but living with all of these parts of the system. We've got a quick comparison between Puget Sound on your left and Chesapeake Bay, two of our major estuaries in this country and in this continent. Puget Sound, as you can see, it gets very, very deep in places with the blue and the intermediate colors. It is a drowned glacial fjord system. The Chesapeake Bay, very different, and most other parts of the world, very different, very shallow, muddy bottom, low relief, and then you can see sort of a drowned stream, drowned river valley in the Chesapeake. You can see all those old river valleys that now are little bays. But back to the left, we had tremendous depth of water down to 600 plus feet, all scoured out by the glaciers. So that's kind of where our story starts, is the glacial scouring, shaping, depositing all these sandy, gravelly, silty banks we have. So Puget Sound is all of glacial origin. We would have had ice filling this basin. I'll show you in just a second. Literally tons of sand and gravel all the way down to silt size. Many of these deposits you'll see in these bluffs, which were cut into the old glacial deposits. We have a lot of variability north to south. The waterways run that way, but there's a lot of change along the Puget Sound Basin, even from Kitsap's north shores to south shores. Most of our shores are very limited with wave energy. The open water distance, or the fetch, is very limited. Of course, the east side gets a little more wave action than the rest of the county. Tidal range changes going south, as do precip patterns, rainfall. So if you could turn the clock back a mere 12,000 years ago, and you squinted your eyes just right, you might see something like this. Of course, the ice sheet wasn't quite this high in one place, because this is sure enough Greenland is the photo, but we had a mile of ice over the northern Puget Sound. And that's what depressed the land, pushed it down, scoured out all these basins, and then dropped all kinds of sediment along the way. This was the extent of the ice on the left, filling all the way past Olympia, past the Puget Sound boundaries by quite a ways, all the way up into the foothills, a mile high in the north, and 2,000 feet high in the south. Water was flowing out the Chehalis, out to the ocean, was flowing out under the ice that was in the Juan de Fuca lobe. Of course, the same situation on the right without the ice. So the topography in the sound, and of course, you can look right there in the center where Kitsap County, of course, is the heart of the Puget Sound. You might consider. I don't live in Kitsap myself, but you can see the lineation or the carving of all of the upper elevation lands and these, almost drumlin shaped, if you're familiar with that term from the Midwest, torpedo shaped hills. And then in the southwest, down by Shelton, everything bends out towards Grays Harbor, Chehalis area. And then we have some very high relief bluffs, particularly along Puget Sound side in places, and the very deep main basin, the blue, dark blue, 600 feet deep parts of the sound. Hood Canal, very deep, but not on the northern end, where it's actually relatively shallow. So we almost have no bedrock at all. I think we see just a little bit showing up down towards Hood Canal, the Great Bend. Of course, across the way in Jefferson, we have a little more, but primarily all glacial sediments. Bluffs are the most pervasive landform. And it's about 5,000 years ago that the ice was all melted and the water came back up. The land finished rising, and the current shorelines and the bluffs were formed in the past 5,000 years, so still evolving today. And our typical layer cake is, well, there is no typical around here, it keeps it interesting, but one of the common situations is we have a very hard, dense sediment at the top called glacial till, often called hardpan. It kind of makes your shovel ring when you bang into it, when you get a solid piece. And then layers and layers of sand or sand and silt clay beds, silt or clay. In this image, we can see lower down in this slide scarp, we can see water flowing out over the clay beds. So that's a common issue, and a common issue with slope stability I'll get to in just a minute. So it is the geology that influences the water, that influences the triggering of landslides, the types of landslides, and then that trigger what changes on the beach and what goes into the beach system as well. So this is one of my favorite beach access photos. This is for the young and the brave. The bluffs come with all sorts of different types of geology, different challenges for putting things like stairways on or decks, or the old boathouses that used to be at the bottom of the bluffs in places. Here we can see lots of sand and some coarse gravel beds. So that material is more easily eroded. In this case, we have a lot of change agents. One being, the combination of natural processes, the waves, rainfall, groundwater, surface water, vegetation. We mix into the equation the sea level rise and potential increased storminess. And then we mix in real site-specific things, local structures, point sources of water, things like that. So just trying to introduce these processes again. It's a combination of things that causes the bank recession at the toe. It might be the waves. It might be water from above, even wind in places from above. And like I said, the human-induced erosion, the structures, the wakes, all sorts of other things that we do. So talking about bluffs a little further, we've classified these into what's known as feeder bluffs and transport zones and accretion shore forms in general. So the feeder bluffs is a term coined in the 70s, bluffs that are feeding sediment to the beaches. So that's got to be more than a very trivial amount. So that's all the blue and the purple around western Kitsap here, Hood Canal region. Blue being feeder bluffs, the purple would be more the exceptional, the really rare high input bluffs. So not really rare, but uncommon. We completed mapping sound wide years ago for the state and have this throughout the sound. It's available on a Washington Coastal Atlas website as well if you want to look for that yourself. We'll be providing some links after this talk as well. So what drives the erosion and primarily landslides Here's that classic situation with Vashon Till. If we look on the right here, Vashon Till, very dense, just a little bit of topsoil above it, a large sand unit, and then a Lawton clay or another clay unit. So the clay is a little more resistant. Water can percolate through the till in cracks and in weak spots and low spots, goes straight down through the sand. It flows laterally across the clay surface. So this can be the cause of shallow and sometimes deeper slides. Whoops, getting ahead of myself. Sometimes these shallow slides above or below or down here, occasionally very deep slides, which are more common with the clay than without the clay. So I'll introduce those superficial shallow ones first. The cartoon at the left here, very simple. This is more of a mid-bluff failure. It might go to the top, it might not. Even with a bulkhead at the bottom, we can get these shallow slides. They're often initiated by prolonged precipitation. And in this case, we also have surface water coming down. We also have some groundwater coming out on the lower middle part of this exposed bank. And then you can see the the rim and the scarp at the top, where there's only 1 or 2 feet of soil loss. That's pretty common in these shallow slides. The roots only get down a certain distance. They help retard slides more than they create them. We'll get to that a little bit later, and you'll hear about vegetation from others. And then eventually there is a failure, and you might lose some of those trees and just a little bit of soil. Sure enough, the house at the bottom of the slope is in a much higher risk than the house at the top. You get things like 20 tons of soil coming and root masses, and that's a high risk situation, particularly in the wettest part of the winter. So some quick examples of how this shows up on the topography. We have this thing called LiDAR now, lasers from planes, and they can see through the vegetation quite well. You can see some of the city grids in these photos. But we can see on the right a whole series of historical shallow slides. Whoops, I did it again. And one larger, potentially deep-seated slide. But these are, most of this might be vegetated. You don't see the trees in this, like I said. On the left, we have very small historical slide chutes visible all the way along this high bank shoreline. You can see a road right on the top of the bank, which is one that was going to be moved back, and it was partially, but that's a whole nother story. We'll be seeing more of that in the future, I'm sure. And then the really truly scary one, this is one of the larger ones on Puget Sound in the last few decades. This is down in Woodway in North Snohomish County, also protected by the railroad on the bottom there. But it perhaps was no coincidence that this slide let loose when a train was rolling by, a freight train. Actually knocked some of the cars right off the tracks. So the vibration probably played a role, but the trigger was the amazing amount of rainfall in 1997, no, 96 it was, I think, right before New Year's, and then clay-rich aquatards holding up the water. So that's the picture on the left, clay-rich beds, groundwater flow, larger deep-seated slide, right over the top of the bulkhead. So again, these large volume ones are uncommon. There's not many spots around that are typically susceptible for this type of slide. Sigh of relief. So a little bit more on the deep-seated slides. This is an example from Whidbey Island, the Ledgewood slide from what, 6-7 years ago now. And this was the LiDAR from before and the photo from before. Notice there's a mid-slope bench. You can see that in both images. There's a road that goes down halfway down the slope on an old landslide. So this was a historical landslide area. What's happened before can happen again, and that's sure enough the case. So I'm going to show a new LiDAR image right on top of this one. See if you can see the difference along that roadway. Sorry, this is the before. We zoomed in. So the before is along the roadway. Here's the after. So all of this blew out. The slide only let go for a percentage of the length. I'm going to go back again, 2005, 2014. I think this was a 2013 event, if I remember right. Luckily, no loss of life. It was kind of a miracle, in fact. If we look at it right after the slide in Google Earth image, you can see the upper bluff let go, and some of it came all the way down. Some of the lower bluff let go as well. So like I said, amazing, nobody lost their life. That's a person, that's an engineer, and that's a streetlight in the middle of this photo. This is within the first month or so after the slide. Again, this whole reach was bulkheaded here as well, but it really did nothing to change what was going on. You can see some of the bulkhead rocks are pushed out by the slide. And this was mapped as unstable old slide. This is this mapping in the bottom part of the image, left shore here, the west shore. Unstable old slide from the 70s. There was a small recent slide, another old and recent slide. So a highly active area. It's a little bit like the far side of the Hood Canal on the Jefferson County side, termination point. Highly active area, best avoided. Looking at in Kitsap, looking at just north of Kingston, that's the Kingston Ferry Terminal on the far left. On the far right, we can see all kinds of evidence of a massive slide area. There's a slide scarp that starts somewhere around this White House and it contains the entire bank going north. You can see some downed trees and some recent activity in 2016. And then looking at the slope stability mapping. So this is that same old 70s mapping transferred to the digital age on the Washington Coastal Atlas. You can see that on the top. So unstable recent slide is mapped in this red color. This whole complex north of the Kingston Ferry Terminal is that. And then unstable beyond that, coming around the point, and then series of recent slides in the 70s on the North Shore. Modified land at the ferry. So I'm going to keep looking at this same area just north of the ferry. And this was some mapping that was done of landslides in Kitsap County by the U.S. Geological Survey in, it was about 12 years ago or so. So you see we're just north of the ferry. They have a landslide scarp going along the high elevation bluff crest. And then there's a couple of roads and houses down here in this potentially active area with some other fresher scarps down below. So there's some other mapping like this, and there's an inventory of slides from this, I think it was around 2007 study. Looking over by Port Gamble and the Hood Canal Bridge area, slope stability again from the Coastal Atlas, you can see unstable recent slide and deep-seated slides across the Jefferson County side. Termination point, it's quite a name, termination point. Not sure I wanted to live there. I can't hear you guys laughing, sorry, I'll just continue. So then some old recent slides south of the bridge. And again, we have unstable peppered in various places going north, but much smaller areas around here. Unfortunately, they didn't map within the federal reservation boundaries or within the Navy base. It was a state-funded program. Okay, so I got a quick Bluffs video from Pritchard Park East area, so we're just south of the Winslow ferry dock on Bainbridge. Let's see if this plays. So these are some unstable bluffs, not eroding probably quite as fast as they look, but these surficial slides, these are not deep-seated, surficial slides of alder trees coming down at periodically. Very steep bank. This gets a lot of ferry wake and a lot of main basin Puget Sound wind waves as well as ship swells. And then one of the classic filled areas with a lot of fill added waterward down there. Has been fairly active since generally our high bluffs that get wave exposure have been more active since the storm of 2016 than they were for decades before that. I'll go into that as well. Sorry, we already got that. Oh, there we go. Okay, so just the last bit on bluffs for this little portion. Water, huge issue. The bluffs are naturally unstable because they're steep, they're over steepened. And then we add water or we continue to have natural water flow, and that only feeds to some of the instability. So what is the things that humans do to add to the natural rainfall infiltration, natural groundwater seepage. Beyond that, we add weight to the top of the slopes at times with fill, with heavy walls, with buildings, things like that. Sometimes people cut into the toe of the slope, which definitely makes them unstable. Removing vegetation or adding water can also add to instability. So surface water, we can put in driveways and parking lots and not control the drainage. That's going to force water towards the bluff in many cases. Remove vegetation, which takes away the vegetation pulling up the water. Evapotranspiration, blocking the water, having water come in on the leaves and evaporate, go into the roots, so on and so forth. And then we add septic tanks with water input, we water lawns, we do all kinds of things. So all of those are important for bank stability. And we'll talk about, like I said, some of the management at the end and also next week. So coastal landforms, we've got all sorts of different issues on bluffs with stairways as well, with the bulkheads I'll get to. We've got different types of shorelines. And then we've got development, sometimes redevelopment, and other times with less than adequate setbacks. Many of you are probably here because you have houses that were not built to the modern setback and you're concerned with them. Avoidance is the easiest. Well, if it's too late, it's too late. You sometimes have other options. So we'll talk about all these things here. Let me keep moving. Lots of coastal landforms or shore forms we talk about. I've already introduced the bluffs. We're going to talk about barrier beaches briefly, lagoons behind them, barrier beaches and estuaries behind them. And occasionally we'll talk about pocket beaches, but not much. And we certainly don't talk about rocky shores because you wouldn't be here if you lived on one. There's no erosion there. When I start talking about the coastlines, I need to say that in some areas, the beach is quite wide at an extreme minus tide, or if you're out snorkeling, the beach might go for 1,000 or 2,000 feet in places. So that is part of the beach system. This sediment is in motion. So it's, it's not just the upper beach we talk about. Some places narrower than others till you get down to very deep water. Over on the Seattle side, in this image, we can see some evidence of submarine landslides into that 600-foot deep basin. So we're not going to worry about that, but we do think about these platforms as part of the system. Who else is part of the system? Well, every organism living in the Puget Sound. So this isn't exactly a food chain, but it's similar to one. Each one of these topics on the right is a subject of a white paper. One on the left is one that I wrote with one of my employees, Beaches and Bluffs of Puget Sound. So these were contracted by the Army Corps of Engineers and this PISNERP group that was together, an agency group. And there's a paper, like I said, a 25-foot, 25-page approachable paper on each of these topics on the right. So the forests and the beaches and the bluffs provide the base of the habitats. Eelgrass is growing there. Everybody's living and hiding in the eelgrass. Forage fish are spawning on the beaches, and everybody above here is eating all of them. And of course, humans could go even above the orcas because we're eating many of these things and certainly controlling them. So that information is available online too, and links can be provided. So our typical erosional beach, again, isn't always typical. Here, even in this one photo, we've got a small accretion beach in the center and more stability on the left, and clearly an erosional beach on the right and much narrower with an erosional feeder bluff. So the sediment size depends, and the sediment input depends on how much wave energy it gets exposed to, how big and high the beach is, and what's the available sediment primarily from the bluffs. Rivers provide a very small percentage of sediment in the Puget Sound counties because they're far away and the rivers flow back into bays, which are pretty much away from most of our shorelines. So waves shape the coast, and the bigger the waves, exponentially more wave energy. You can see on the bottom left, big storm swells, and that's what's doing the big thing, the big changes, these couple events that are the largest of the 2 to 5 year period. Those are the ones that are doing the big change on our shorelines. A little bit of a car wash on the ferry. Some waves are bigger than others, but certainly these November January type storms that can be the largest. When waves are coming in towards the shoreline, in the bird's eye view here, when it shoals up outside of a headland, the waves will go from a linear form to bend or refract as they advance. So the wave energy tends to be focused more on these headlands and these points, and you tend to have faster erosion rates. Tidal range is another thing I mentioned quickly earlier. The difference between the high tide and the low tide is much greater as you go south. So it gets all the way up to 14.5 feet in Olympia, starting more like 7 feet out in Port Angeles, just off this map. So the further you go down in the county and in Hood Canal, the more the tidal range, the more the wave energy is dissipated across a broader beach. So that's why the beaches are wider in South Sound and the waves come up and go down pretty quickly with the tides. And then, like I said, it's these big storms. This is the March 10, 2016 storm, which probably some of you remember, early morning. And the tide was running about 2 feet higher than predicted. And that's due to the big low pressure system of the storm. The weight of the atmosphere is actually less and the water surface rises. So this was flowing into yards in many places. Then the December 20, 2018 storm was a really big one at equally high water. But wait, it's not over. We had one just a week ago, on January 13th, a couple weeks ago. January 13th here in Seattle, we had a 12.6 tide predicted, and then we had a 14.2 tide recorded. So that's the king tides and the storm surge on top of that. So I'm sure some of you experienced some change in that storm as well. Ordinary high water, I just threw in here. This is a jurisdictional line. Just very briefly, as far as jurisdictions for people that permit any change on the beaches and the banks. We've got federal jurisdiction on the beaches till this predicted high tide of the year or a multi-year period. We've got state jurisdiction up to the toe of the bank, sometimes a little higher to the ordinary high water here. Ordinary high water on an accretion beach might be through the logs and through a dense vegetation band or through the front of the dense vegetation. And then all of this is in county jurisdiction, all of the beach and 200 feet landward of the high water. So that's an important designation for jurisdictional lines. And it's a bit of a moving target with vegetation as well. Doesn't keep the water out though. On a king tide day, we can easily get some of this coastal flooding in these low spits in particular. So one of our other hazards. The drift logs are another player. Typically, they can dampen waves and erosion. They let windblown sand deposit. They make cooler, shady spots for vegetation, and as well as critters that bugs, particularly that birds and fish actually eat, and do make extra bird habitat as well. However, when the storms get really high, the waves can get the logs moving, and they can do some damage that sometimes is worse than without the logs present. Like I said, they help you until, in some cases, they're not helping. Some cases we anchor logs in soft shore protection, but again, that'll be next week. There's some really big barrier beaches and so a lot of small ones in Kitsap. This is Indianola Spit. And this is an area that gets a lot of change and deposition of debris many times during those big storms I mentioned. We have this thing called overwash where we're looking back towards the bay in this case, and gravel and logs get washed over the top. It's a natural process. That's how the barrier beaches tend to recede and roll over the top slowly, but during big storms, it's when we try to stop that is when the debris actually can cause damage. But it is a way that the beach feeds itself. The spit gets higher during sea level rise in a storm in a natural setting. Of course, it always recedes a little bit at the same time. Okay, so looking at 3 dimensions, we've got littoral drift or net shore drift. And it's the bluff sediment like these slides, small and large, that provide the sediment. And then it moves along shore in one direction. It moves sometimes both directions, but there's a net direction in pretty much every case. So here's a simple example. North Kitsap up at far north end of Fellwether Bluff area, there's a divergent zone. And then there's a drift cell that comes down to each of these cuspate forelands. The spits at no point, for example, twin spits. So that's the deposition is at the tip of these spits. On the left is an idealized representation. The feeder bluffs are these hatched areas, sediment input. You get sometimes small deposition areas, minor stream input, sediment input, more feeder bluffs, and then a spit at the end. So that's a common, but not always the case. So again, waves coming from this arrow here from, let's say, the southeast on the left pane. Kitsap County drift cells shown here in colors. So along this main Bangor area, this would be so-called right to left. That means if you're in a boat in the water, it's going from right to left, all the way out to the Port Gamble spit. So it's opposite here, left to right is the green over across the way in Hood Canal. So if you notice, most of these are going northward because mostly we have dominant southerly storms in the winter. Where we have no exposure to the south, like at Fellwether Bluff, that's when you have a southward trending drift cell. Same thing on the Jefferson County side. But again, most of these are going north in the main east shores of Kitsap as well. So what are coastal erosion rates? Have you ever seen a house like that on the right in Kitsap County? If you have, please let me know. This is an East Coast Barrier Island hurricane, post-hurricane storm, where you get huge amounts of change in one storm. We had a huge storm here, the New Year's 96, 97 on the lower left. So Whidbey Island slide, slide of a slide. But the typical long-term erosion rates are 1, 2, 3 inches per year. Some places less than 1 inch. So that's about the fingernail growth, not quite as scary as the East Coast hurricane. So it can be managed. First, you need to understand it. These are an erosion rate study we did for a state agency a few years ago. And the more red, the faster the erosion rate, up to 1.2 feet per year, exposed to the Strait of Juan de Fuca. You'll notice the rates get lesser as we get down into the Sound. You'll also notice we didn't get a lot of good rates in Kitsap County. We didn't have a ton of undeveloped shores to measure natural erosion on from old monuments and old landmarks or unbulkheaded shorelines in Kitsap County, it turns out. But we do have a handful of sites. Again, this highest one is over 1/2 foot per year. And then most of these are, 2, 3, 4 inches per year. All these oranges were down in the 1 to 2 inches a year, and all these tans going south. One higher one here where it's exposed to a larger fetch north of Seebeck. So these rates, if you average all these together, all around the Sound, it would be about 1/4 foot per year. There's some statistics on the left. Most of these were from 50 to 70 years in length, so good long-term rates. And yeah, like I said, about 1/4 foot per year was the long-term average. And we didn't get to measure places that weren't really eroding noticeably because there was no air photo to use to see the exposed bluff. These are all bluff shores. So these overestimate all the bluffs around the Sound. The ones that are fully vegetated are not hardly eroding at all, and we couldn't get any measurement points off them. Other measurements here were done by monuments over many years. Okay, so we're more than halfway through. Angie, is there any questions that came up, or do you want to see if we want to take a few questions?
Yeah, absolutely. Awesome. Okay, let's see. I'll check the Q&A now. Okay, I have one question so far. It says, I'm not sure that I got that. Did he just say 1/4 inch? The slide says 1/4 foot.
1/4 foot per year, 3 inches per year is one of the big averages.
Got it. Okay, awesome.
My mistake.
Thank you. Okay. All right. And then if anyone else has questions right now, if you could type it in the Q&A. Oh, okay. I've got another question it says, what does faulting contribute?
Okay, so faulting would be a geologic term of, fractures in the crust of the earth, literally. I mean, in terms of geology, that would be the larger faults. It doesn't contribute much, but we do have an old fault that runs through southern Bainbridge, the Seattle Fault. It used to go over more or less to the Kingdom. Restoration Point on southeast Bainbridge has vertical uplift of, I'm trying to remember, 15 feet, something like that, from 1,100 years ago. So that had a lot of impact 1,100 years ago. We have some possibly quasi-active faults, but not much that we can see in the last 40, 50 years. People have been looking closely. If we have tremors, that can instigate slides in different areas, especially if it's wet out. But yeah, it's not a common to have major faults that are causing any of these slides.
Awesome. All right, I've got a couple more questions here. Try and get through these. So we've got, is Puget Sound going up due to tectonic uplift?
Oh, excellent question. I think I do not have a slide today on that. Sometimes I do. That's a great question. So we've got some big picture geology. We could spend all day on this, right? Well, who needs this shore-friendly stuff? No. It's a great question because southeast Puget Sound is actually subsiding a little bit. So Olympia, Tacoma are actually, particularly that area is going down a little bit as the outer coast is going up a little bit. So that is the tectonic picture with the ocean plate going under the continental plate and forcing the outer coast up a little. And it's hinging kind of through Hood Canal to Point Roberts area at a 0 rate. And then eastern Kitsap will be going down slightly. And like I said, Tacoma going down more. However, when and if the big earthquake comes again, that's all going to readjust. Tacoma is going to pop up. The bay is going to fall down. We're all going to fall over and cover our heads. And, that's sort of a short-term buildup. And then the big earthquake relaxes all that strain. Try not to scare you too much, but we expect a major subduction zone earthquake between 50 years ago and 800 or 900 years in the future. So we're in the big window of time when it will occur again.
Awesome. All right. Do you have time for one or two more questions, Jim, you think?
Yeah.
All right, perfect. Okay, so next one, is there a difference with estuaries in terms of bluffs?
Well, estuaries by definition, it doesn't really matter what's around them as long as they have a semi-enclosed bay and some amount of fresh water. So they're all estuaries. If there's bluffs around them, you would probably have a little more sediment input, more potential for wider beaches and some other subtle changes. But still the estuarine process, the saltwater process, probably be pretty darn similar. And any situation, those are prime habitat areas for salmon and many other species. So that's why they get some extra protection in the regulatory framework.
Okay, great. And then last one for right now. All right, we've got how far back from the shoreline do you study? You mentioned tree removal. How far away from the shoreline would how far away from the shoreline would this affect the shoreline?
Well, I'll give you a couple examples of vegetation. Like I said, we have 2 other presenters in these 2 different weeks on that topic. When I talk about vegetation management relative to bluffs, we're talking about the entire bluff face, and the 20, 30, 40 feet behind the bluff crest is really important. And the more vegetation, the more it can help with stability, to make the long story short. There's a lot of habitat issues as well that come into play. Overhanging vegetation on the water line tends to make shade, which makes the water cooler, which keeps the little fish eggs cooler and more viable. Drops bugs and things in for Chinook salmon. Endangered Chinook salmon adults eat insects that fall in from trees and shrubs and things. So there's a lot of habitat issues as well. So it's really, but when we talk about management for stability, it's really the bluff crest plus 20 or 30 feet and then on down. There's water quality that goes much further landward. We're talking about 200 meters at times for or even larger for water quality buffers are ideal. So maybe I should keep moving then. We got another segment here.
Yep, sounds great. Thanks, Jim.
Okay, thanks for those. There'll be a little time for questions at the end as well. I wanted to just do some in the middle. Okay, so talking about modifications, bulkheads, habitats, and drainage now. This is a Big Beef estuary, Big Beef Creek area, Hood Canal shore. Many of you have probably driven this road that runs right across to a relatively short bridge going south and west to the left. This is the original spit. If you can, Angie, can you guys see my pointer? I should probably double check.
Yes, I can see it.
Okay, thank you. So this blue shoreline was the old mean high water line in the 1880s, I believe. So this opening here was probably 600 or 700 feet. So this was a lagoon, partially protected, so an estuarine lagoon. There is a salmon stream up here that University of Washington does a lot of research on. And then somewhere back in the old days, they built a wooden trestle as these yellow lines. That all fell apart. So they came out with bulldozers and modern equipment and filled all of this and then put a shorter bridge in. So this was a Pisner Puget Sound nearshore estuarine restoration project, federally funded conceptual design that we were part of years ago to open this all up and to bring it back to a long bridge, and something like was done at Killisset Harbor recently in Jefferson County. So it's just one example of a big modification. Hood Canal Shore has countless numbers like this. So all of these have contributed to degraded salmon habitat, some much more than others. This one at least has a fair-sized bridge, much better than a culvert. So that's one bigger example. Much more common are the shoreline bulkheads. We call them armor structures or shoreline armoring, sometimes called modifications as well. So classic example on the left of a rockery wall or a revetment. This one's kind of a blend of the two. Oops. And then on the bottom right, these are cross-shore groins, which have been outlawed since about 1976, 77 by shoreline master plans. But some of these are still legacy structures. So those literally block sediment along the beach, and they cause erosion on the downdrift side, as well as downdrift erosion for quite a long ways by blocking sediment. So these are some of the impacts we see about shore armor in Kitsap County. This is the southern central part of the county. And the more the red, the more percentage of that unit is armored. It has bulkheads and other fill. That's not a natural shore. So the real red is 80 to 100%. And Port Orchard, Bremerton area, of course, are some of the poster child for shoreline modifications, South Bainbridge. And then the further away you go from there, you get fewer percentages of armor, long story short. So this has been of great concern to the resource managers for a number of reasons, and I'll show you those. They directly bury the beach. So you can see at high tide on the right, there's no beach left where there's the wall. Even on the low energy example on the left, they come out some number of feet and bury the upper beach. And then we get that takes away the berm, the big storm berm, which is sort of a sediment reserve during storms. It comes into play. So that's usually excavated out first thing. Increased wave reflection off the front of the wall causes more beach scour and causes beaches to become coarser. It also causes an accelerated littoral transport through the system. That's been quantified a handful of places. And then something that's really obvious is this end erosion around the wood wall on the right. There's a giant scallop of erosion which progresses up slope. Even on this little low energy one on the left, there's been end erosion and they kept throwing these field stones at it. You can see there's voids. So it's an ongoing problem. It's much faster than natural erosion. So those are the site-specific impacts. Of course, if one person builds a bulkhead here, causes erosion next door, the other person typically wants to build one, and there's a real cumulative impact of proliferation. In the bigger picture, they reduce the sediment input from the bluffs, which is the primary source, like I said. Got plenty of peer-reviewed journals on that, articles. And then the beach tends to get starved of sediment. At the same time, sediment moves quickly away with increased wave turbulence. So on the right, I believe, is a Kitsap County area. We're down to a cobble beach. We've got a footing in front of a footing, which is another footing, is a retrofit here as the beach lowered. More expense, more impact, more loss of beach area. So that's the habitat concerns, as well as the recreation. If you can't get there at high tide, you can't even walk the beach. I mentioned the vegetation loss earlier, the loss of organic input, the loss of the insects and the perches and all those other things. And the cumulative impacts and effects, which we don't even understand. As all these 10 things interact, we really don't understand all the implications that come out of that. And then what's the result on the beach here? This is the simple way to look at the coastal squeeze. We have the upper left is the natural shore. If we have a sea level rise on the right, you know, this case with no armor, the shoreline everything can adjust upwards. House is set back enough. On the left, lower with the armor, we can see as the sea level rises, you lose that upper beach, forage fish spawning in that little checked area there. Whoops. We lose that spawning as it gets squeezed out against the armor structure. And it's the upper intertidal where these beaches provide habitat for surf smelt and sand lance. Those are two of the primary adult salmon food sources called forage fish. So I'm going to try to bring some of this together in a few Illahee area slides. This is a drift cell going left to right, south to north, driven by those southerly windstorms. We've got some historical feeder bluffs on the far left, which are now armored, so reduced sediment input. I think this is Illahee Stream and Valley, very nice coming out of the park. Got a natural spit and a delta. Creeks offset to the right, because that's the way the waves are pushing everything. That's an indicator of drift to the right. And then it continues on. Eelgrass beds are down here in the minus tides, another key habitat for salmon and crab and halibut and things. Going up along the drift cell, more feeder bluff sources, armored historical feeder bluffs. So this is a highly impacted area. Drift continues. And then all the way around to the Gilbertson area, just south of Brownsville a little ways, drift cell terminus, nice wide sandy sand gravel beach for potential surf smelt spawning, and then we're sandy for sand lance spawning. Drift cell ends with this spit, which makes this estuary, which makes this marsh, which makes, you know, tremendous salmon habitat, like I said. So if the sediment gets cut off, we often see these spits erode. And we see these beaches erode and those habitats start to go away. So just for a quick summary there's just a little bit after this. It's the waves that are shaping our coast, wind generated waves in all of Kitsap County, a little different in the Strait of Juan de Fuca where we have a swell. Bluffs typically provide around 90% of the sediment for beaches. That's, you know, a rough average, but only locally do we have any stream sediment that's of any volume. These coasts are continually evolving. So there's erosion, transport of sediment, deposition of sediment, and then the cycle keeps repeating and changing depending on varying conditions. The net shore drift forms and maintains these beaches and the nearshore habitats. And that's why the coastal system is the term that is being used more and more. And drift cell management, it's when you're in a beach unit, it's not just your property or your subdivision. It's, you know, it's that whole region. So the drift cells are one of the best ways of understanding the coast. Just back to that habitat issue for a second. Here's our simple food chain from the beach. It's these surf smelt primarily that are more common than sand lance, that are these forage fish. The third species is herring that spawn down in the eelgrass and the red algae. They're in trouble in a lot of places around here. So the surf smelt we think are doing better, but again, they spawn on the upper beach. So that's right where the development can occur. That's the food for adult salmon, and that's the food for the orcas, which are now listed, of course, on the endangered species list as well. Here's a picture of the state's former forage fish habitat biologist. He's retired now, but standing on top of a spawning area. This kind of pea gravel, fine gravel sand area is prime habitat for surf smelt. Here's one of them with a nice old school phone from years ago for scale. And then sometimes you can see little specks that are their eggs. I'm not sure about this photo, but a lot of times you see these little specks on the egg as eggs. And they like shade. Even they're under these under this old barge, which is a creosoted wood nightmare. The eggs would do better, at least in terms of shade and temperature. Not so sure about the toxins. So where there's natural vegetation, the shade keeps the eggs alive is the natural situation. So here's an area that was armored decades ago for a road, and these riprap is now what's there. It's terrible substrate. You can't bury your eggs on a rock. These are surf smelt eggs, these white dots, if you can see them on the left. And basically they're frying in the sun here. These are all dead. But this same area, we came back and did a beach enhancement. So this habitat is pretty much gone. This subspecies of surf smelt was almost extinct. And I'll show you a few minutes of a quick enhancement we did at that area. So I can't do this talk without talking about global climate change for a minute. It's a bit of the elephant in the room, if not. So this is from the National Climate Assessment that came out a year or so ago. And we talk about, the year 2018 when they did this study, started this study. What are the scenarios? So there's a high emissions scenario going forward, lower emissions scenario that drops off, and a super optimistic, most would say unrealistic scenario where our emissions plummet pretty soon. So depending on which of those carbon emission scenarios you use, you get a low, a medium, or a high temperature change, as well as a sea level rise. These are degrees, well, the high here is 7 degrees Fahrenheit, which would be, absolutely amazingly different from today. And the sea level rise, which is the next slide, has a huge range of outcomes as well, from these super optimistic low scenarios and dropping emissions to up here, which people think is the track we're on now. Emissions have not gone down much except a little bit due to the pandemic, to the really high, almost very slow emissions reductions. So here we're talking about change in sea level in meters. So 2.5 meters, 8 feet is sort of the extreme high projection here. Most people are talking about 3 to 4 feet of sea level rise, 2.5 to 4 feet of sea level rise by 2100 as sort of the mainstream projections. Others are talking about 2 meters, 6+ feet. So 2.5 to 4 feet is a lot to wrap your mind around for sea level rise, and we have to start thinking about it. It's already gone up 7-8 inches since the 1900 turn of the last century. So that's always causing impacts. It's going to be going up much quicker. And as a society and as neighborhoods, we better start thinking about this and thinking about some significant changes. I'm not going to go into a lot of more detail, but I guess I put those in the wrong spot, because here is those rocks that spawning was going on. And we have simple short to medium term things we can do for this kind of habitat degradation, and they are adding beach sediment. So this is a simple project. We're doing more and more of these. I'll go back again. Before, you can see the background's the same, and after. This is not a permanent solution, and it gets a little bit more complicated to maintain this with sea level rise. But we have more and more restoration projects that are trying to remove armor and put things back in place. So I'll go into that more in the next webinar. A few quick resources: the Marine Shoreline Design Guidelines, easily found online. This is a large study. We wrote this one with just a little bit of help, going over how to understand these shores and going over what you can do for management of these shorelines. Just a few quick examples. We look at different causes of erosion at one point. Cross-shore structures, one example. Wakes being another. Interruption of sediment transport due to bulkheads being another. And then the second half of the document goes into a full suite of alternative management techniques, from restoration on one end, passive management, some things like drainage I'll talk about next, soft shore protection, beach nourishment being a big tool, large wood, resloping banks, and then the traditional hard armors structures, the revetments, seawalls, and things like that. So those are explained in a lot of depth in the Marine Shoreline Design Guidelines. And there's 25 case studies, again, managing to miraculously skip Kitsap County for what was done of all those different techniques and how did it work and what did we learn from them. And then there's this risk-based decision tree in the design guidelines, which helps to get to different appropriate management techniques to try and evaluate. I'm not going to walk through this. It's a little more complicated than some, but we created this with a serious peer review process and feel this can be helpful for deciding what to do at sites. Okay, so I'm going to talk about drainage to wrap up, but without, I need to mention water quality. There's a lot of concern of taking unfiltered water, stormwater, and running it down bluffs into Puget Sound. So there's a lot more controls on that nowadays. We don't want to be taking road or parking lot or driveway water, which has hydrocarbons in it and a whole host of other things, and killing fish with it, because it's been shown to be highly toxic in streams. And there's no reason to think it's not toxic in marine waters as well. Obviously, it gets diluted more, but it's a death of 1,000 cuts we found is the problems in Puget Sound. So we're talking about taking yard drainage, that's wet areas and particularly unstable slopes where there's development at risk, possibly taking that to Puget Sound, possibly running it out into the forest, things like that, but definitely not taking hard surface drainage. So classic example on Puget Sound drainage is to run to Home Depot and get a roll of 150 feet of thin black corrugated pipe, connect it on the top, put a few hose clamps on and roll it down the slope, and there your drainage is gone, it's taken care of. What happens 5 years later? A tree falls on the pipe breaks. Maybe instead of the tree, it's the pipe's blowing around in the wind and it abrades right through on the bluff and it's leaking water. Maybe it's just UV damage after 10 years and the pipe is brittle, it breaks apart, water's leaking out and through little holes. All of that is worse than having no drainage control at all. You can see this broken pipe from the top on the left. It's caused a lot of erosion in a gully in one short part of a winter. I've seen this, I don't know how many times all around the region. So the plan then is to figure out, A, is there a risk? Is there a house that's at clear risk or a drain field or something? Is the water volume high? Is everything wet? And then, if so, it's probably worth some measure of drainage control. So kind of make a plan, make a map, figure out where things are going naturally and with, roof water. Is that coming straight out towards the bluff? Again, we want to avoid this 4-inch corrugated plastic on high bluffs because it just doesn't last. The best solution is a high density polyethylene, HDPE. It's also much higher cost and it lasts for much longer with much greater security. Many times it's good to share between a few properties to share the cost if you need to get water down the bank. Like I said, running it into infiltration trenches into the forest or the side yard can be a much simpler and cleaner solution. Cheaper, it's certainly cleaner for the water quality. So you want to plan all that at once, figure out how to tackle it. Civil engineers and engineering geologists deal with these kind of problems. And then put that plan into place. So this is an example of no drainage control and making all the drainage issues worse. They cleared everything, they cleared the bluff face, they threw construction debris on the bluff. they watch the erosion rate double after development. So from 4 inches a year to 8 inches a year at this high energy shoreline. So we got to learn from these folks and not do all those things. So I think I've talked about most of these things. Ideally, we're building far from the shorelines, from unstable slopes and beaches. We're limiting clearing. I don't think I mentioned that, but limiting the clearing, and this topsoil disturbance keeps from limiting and eliminating a lot of the big vegetation. Tight lines, we want to avoid them if possible, but if needed, the drainage tight lines should be the HDPE I mentioned, or something very much robust. And retaining vegetation on the bluff and above the crest is very beneficial for erosion control, as I mentioned. And look at that, where we've got a few minutes for questions. So Angie, you want to take over again?
Awesome, sure thing, absolutely. So I have a couple questions in the Q&A. I'll get that started here. Okay. All right. So first we have, this one was from a couple minutes ago. So what are the most significant things humans have done to increase the erosive rate, breakwaters, large ship traffic, etc.?
All of the above. Now, what are the most significant things? I mean, it depends different areas, but the areas that were naturally unstable, where we've really cleared everything without putting in drainage control, is probably the biggest change. And then in a few other areas, you know, that's really, drainage is really the thing that's easiest to change for the negative, and usually for the positive as well. Surface water and groundwater, but particularly surface water is easier to control. I've had, I don't know how many places I've gone out to where people say, you know, the bluff wasn't really eroding until that whole new road and that clear cut and that subdivision and that mini mall went in over there. And they didn't do all the right drainage work, and now everything's changed, and look how wet it is, and so on and so forth. But with that said, you know, ship wakes can be a big impact. Bulkheading in places like South Kitsap County, Bainbridge Island can be a huge impact, because we've eliminated most of the feeder bluffs in South Bainbridge, for example, and parts of Sinclair Inlet and other parts. So you have no natural sediment input, and the beaches get down to the clay. You know, there's no beach sediment in places. So that's a huge systematic change too.
Awesome. All right. Thanks, Jim. Okay, next question. Says, we noticed deformation in the bluff sediments. What is this from?
Okay, that's a good question. So in a few unusual cases, we can see sort of wavy lines in the bluff, and that's technically called soft sediment deformation. So that might be what you're talking about. If you can see these wavy lines where otherwise it's horizontal, that is often related to tectonics, to, you know, earthquakes or tremors when that sediment was still relatively soft. So if the glacier just came by and it deposited all these layers of wet sand and it's not really firmed up yet, there's an earthquake, that can sort of flow around like jelly. So that's, I think, what I'm guessing you're thinking about. And I've seen that off and on around the region.
Awesome. All right. I've got another one over here. It says, have we mapped where beaches cut off from their feeder bluffs, where their feeder bluffs are depleted from their sediment budget? Are there examples of where beach nourishment has been permitted as a fish habitat enhancement programmatic, say, to offset impacts from shoreline development? Examples, shoreline road maintenance work.
Okay, that's a good set of questions. Beach nourishment has been used for a variety of things, some being strictly habitat, some being, you know, enhancement, some being soft shore protection, some being strictly for erosion control. So there's sort of a spectrum there. It's been used in front of Lummi Shore Road in Bellingham Bay off and on. It's probably the biggest beach nourishment project in the region of that type. It's since the mid-90s. It's been considered for Dockton Road. I don't think it was ever carried out down on Vashon Mori. There's been a few other road projects. There's a really small project on East Bainbridge at Manitou Park a few years ago with coarse beach nourishment. What was the first part of that question, Angie? Sorry, the other part?
Yeah, so first part is, have we mapped where beaches cut off from their feeder bluffs?
Yeah, and we have mapped all the drift cells. We completed that soundbite database and got it all digitized some years ago. Others mapped a lot of the basic data. We've mapped all the feeder bluffs in my group. All of that's available on the Washington Coastal Atlas by Department of Ecology. You can do your kind of poor man's GIS online, Geographic Information System. And then I showed you that other slide earlier with all the red drift cells with 80+% armor. So, you know, those are the areas we're talking about. And yes, that's all been mapped. And that's gone into some new prioritizations for armor removal for restoration projects as well. So that data is all being used now.
Awesome. All right. Okay. Next one I've got, okay, let's see. For losing 3 inches a year, that would suggest over 2 feet of loss a decade on average. There's no way that bluffs can gain instead of lose sediment short of major tectonic changes, correct? With another question, all our Puget Sound shorelines are disappearing over time.
That is correct. And that's why, you know, if you're redeveloping a site or if you're considering a major addition or something, and if the setback's truly low, it's becoming more and more practical to move houses back in these more risky situations. Most people, maybe they're back 40, 50 feet, 3 inches a year, even 5 inches a year is not going to be a problem for the life of that structure. You know, 3 inches a year, 30 inches in a decade, you know, even, you know, half a century, that's still, you're measuring, you know, in less than 10 feet, usually less than 5 feet. But if your house is 10 feet back, you know, maybe it's a different story. So it's really the high risk sites are the ones where this bluff erosion becomes an issue. And bear in mind, it will be accelerating in the future with sea level rise. So that's, you know, that's the shape of our future, is to figure that out and figure out the management of that. When we talk about, you know, losing a little bit of bluff, there is no code that says you can protect a tree or, you know, a swing set. You know, the codes are designed to protect houses, drain fields, roads, buildings, things like that. So that's the differentiation there.
Awesome. All right, I've got a couple more questions. I'll try and get through these. All right, next one. If you have a tree that falls onto the shoreline, what should we do? Leave it there or cut it up?
Well, the salmon biologists would all say leave the tree there. Salmon have been observed hiding under trees. There's the insects, other attachments, all sorts of things living there. It makes complexity to the shoreline. I do see people after storms cutting trees quite often, and you know, sort of a human instinct is to clean up. Maybe for access they want to do it, but if at all possible, you know, just leaving it there can also help for erosion control. It does dampen wave energy, and the larger the piece, the more likely it is to stay in one place.
Awesome. All right. Next one. This one actually might be able to go to Jesse too, but we'll try it here first. If a tree looks like it's about to fall and pull the bank with it, is it good to cut the tree to reduce weight but keep the root system?
Yeah, that's an age-old question, and it's been a matter of debate for many decades. And you know, when I started in this business 30 plus years ago, there were still people around that said, yeah, cut all those trees on the bluff crest on the edge because they're going to cause it to fall and take bank with it. There's hardly anybody left who advises that blanket now. They're not around anymore. There's been a lot more science on the topic. The root masses tend to help retard erosion for much longer than otherwise that the soil would even be there. However, you know, if you start to see the tree leaning and the roots lifting and the soil cracking and even more undermining occurring, then yes, sometimes those trees should be cut if they're on the bluff crest. And the arborist, certified arborist, is the best one to comment on those topics. But again, you can see these trees lasting for a lot longer than a lot of people expect. So it's really a site-by-site basis. And when it's time to cut them, you know, it's a little more obvious. Again, the habitat features of leaving the wood on the slope or on the beach are beneficial for the critters.
Awesome. All right, I've got 2 more questions here in the Q&A, and then we're gonna wrap up. So this first one, you talked of removal of hard impervious bulkheads. Will you be speaking about how to replace them? Irregular surfaces, are large irregular rocks like drift logs recommended to replace bulkheads?
So yes, that's one of the primary focuses of this next webinar. And can you remind us of the time and date, Angie?
Yes, next webinar will be 1 to 3 p.m. next Wednesday, February 10th, so a week from today.
All right. Thank you. I just didn't want to get that wrong. That'll be one of the primary topics, the soft shore projects, a few restoration projects, and where do they work, where are they not really advised. I'll cover that as much as possible, but again, there's site-specific issues that come in, but yes.
All right, and last question I've got for you, are rain gardens effective on private property?
Yeah, again, Jesse or Jenny probably have some comments on that, but from the physical perspective, rain gardens can be very effective as, looking at it 2 ways. One, a place to put the water that you want to get away from the house or the drain field. And 2, a place to enhance habitat, get more species, get more birds and things you can watch and observe, beneficial for all those reasons. So in terms of the physical stability, again, you want to move it laterally sideways from a house and not in front of it or behind it. And it's a lot of great infiltration approaches and some more common rain garden designs that are out there that, like I said, the other folks can comment on more, but it's also a lot cheaper than maintaining a drainage tight line or something more complicated over time.
If I could speak up at that moment, we actually at the district do install rain gardens. They are effective, and we have cost share up to $1,000 for qualified landowners for that to help them with technical assistance on rain gardens.
Awesome. All right, those are all the questions I have for you, Jim. Awesome job. I learned a lot, so I hope everyone else did too. We're going to transition at this time, take a couple minutes, and then we're going to switch over to Jesse Adams from Kitsap Conservation District, and he's going to talk about vegetation, best management practices, and removing invasive plants on shorelines. So that's how we're going to wrap up today. So right now, take a couple minutes, like 5 minutes or so, get a cup of coffee, use the restroom, whatever you need, and we will reconvene here shortly. Thanks so much, you guys.
Okay, thanks for your attention, folks.
All right, guys, I'm going to give everyone another minute to kind of roll back in here, and then we'll get the ball rolling for Kitsap Conservation District and Jesse Adams. Thank you all again for being here. And yeah, about 45 seconds and we're going to get started with part 2. All right, it's about that time. Jesse Adams is going to be here from Kitsap Conservation District talking to us about shoreline vegetation management and noxious weed removal. All right, Jesse, take it away.
All right, good afternoon. I'll be talking about noxious weed removal as mentioned. And let me click here and there we go, slow to move. No discussion on integrated pest management would be complete without mentioning, no discussion on noxious weed removal would be complete without integrated pest management mentioned. Integrated pest management is an ecosystem-based strategy that focuses on long-term prevention of pests or their damage through a combination of techniques such as biological control, habitat manipulation, modification of cultural practices, and use of resistant varieties. This is going to be the wordiest slide in the presentation, so don't worry, and we'll be coming back to this towards the end. And I really want to make a big point that this is a marathon, not a sprint. When you walk up, look at your property, and you have a wall of blackberries or an entire slope filled with ivy, it can be daunting. And you need to take a step-by-step approach to this. Do what you can, breaking a big project into small projects, say, maybe instead of, if you're doing a whole acre of removal, instead of doing the 1 acre at a time, break it into 10 or 15 smaller projects that you do over time. Whatever you can do with your time and your resources is appropriate. When to act, it is, for best results, you should remove invasive species right before they flower. Plants spend a significant amount of their energy preparing themselves to flower, fruit, and spread. If you remove the plant during this process, you can weaken the plant's ability to recover, making weed control much more effective. It is still effective to remove plants at other times of the year, and a lot of this could come down to what fits your schedule. If, say, a plant flowers in May, but that your kid has a recital, or I don't know, something with your job, you're just busy that time of year, don't be discouraged and think you have to wait till next year. You'll still can remove them at any point of the year. It's just most effective at that time. So if you can do it at the most effective time, do so. Himalayan Blackberry is really common and prolific in the entire Pacific Northwest, and I'm almost positive it's on your property. It flowers in May, and I generally recommend mechanical control, but there are some caveats to that. If you are having really aggressive erosion issues, you don't want to necessarily pull out the roots if it's going to compromise the stream bank, the shoreline bank there. When you are doing mechanical control, you want to chop the stems down to 12 inches so you can access the root ball and still see where it's at. I work with a lot of volunteers, landowners, and other crew where they will be chopping down blackberries with loppers, machetes, or a brush cutter. And a lot of times their first instinct is to cut it right down to the ground. And every time that happens, to the untrained eye, and even to the trained eye, it can be very hard to find where that root ball is. And that's why leaving about 12 inches of stem left can give you a really good marker of where that root ball is. To dig it out, if you can dig it out, sometimes you might not be able to access it. I prefer a shovel. I do know a lot of veterans of blackberry removal who prefer a pickaxe or a mattock of some kind, whatever tool you find appropriate. You're not going to get the entire root ball. That root ball is like a big ball of like a big potato full of energy, and you want to get as much of it as you can, but there's going to be little bits left behind. Blackberry is very good at leaving those. So I recommend removing starts, like the little bits that come up throughout the year, about 2 to 4 times a year. Once you get rid of it the first time, that the big biomass, this big bush, like this man is here in the picture, it's going to be a lot easier and a lot less work, and significantly less labor intensive to pick out the little baby blackberries that are trying to come right back. Especially if you replace the area you cleared with a species, native plant species like a thicket forming Nuka rose. That can really help reduce your maintenance. English ivy is also really common. It flowers in September, but a lot of times it is easier to remove earlier in the year, in maybe July or August, given that it's drier. Sometimes a lot of the conditions where the English ivy is just sometimes easier to do in the driest conditions. I recommend mechanical control where possible. In the picture on the top right, you see us removing it using, I call it like rolling it up like a carpet. We'll use our hands oftentimes. In this case, we're using McLeod's to pull it up, and maybe machete of some kind. I've done this myself pretty well, just by myself. We would roll that onto a tarp, then drag the tarp to our vehicle where we would put it. On that site, we removed about nearly a half acre of English ivy out of the whole area over off of Beach Road in Port Orchard. And it was about 2 tons according to the dump where when they weighed us. That is a big project, and it took us a whole week with a crew of 5 and a lot of man hours to get that done. For your site, you're going to need to be a lot more systematic and break that into probably smaller projects. Maybe do this one bit over here and then slowly work your way over down the slope. And you got to be careful. If it's too steep, you can't actually access it. And you want to be careful not to compromise the slope by removing too much at one time. Ivy is really good at growing on those steep areas. And you can, if it is that steep and the English ivy is that hard to access, you may want to focus more on revegetation and moving smaller and smaller chunks of it, because you need those roots to hold in the soil. In the bottom right picture, I have an example of 2 crew members chopping off chunks of the English ivy off the tree. So they're girdling the ivy stem at the base of the tree. Usually you got to remove about a 6-inch chunk away from the top, from the middle, or remove 3 feet up from the ground. As he was there, he took off a big chunk. That will kill all the ivy in the tree, and it could even save the tree if you could do it soon enough. Sometimes if you wait too long and the tree is really well infested with ivy, the ivy can root itself into the tree, and it can kind of become a parasitic relationship there. And then if you cover the area that you remove the ivy, like we are in the top picture, if we were able to cover that in 4 inches of bark, it makes a huge difference. I've gone as high as 8 inches, and that bark is really effective with the English ivy. If you cover it in a mulch, it makes it really hard for it to come back. And I have had really good success with that, which that won't be applicable to every property and every shoreline. But if possible, that can be very, very effective if it works for you. And replanting with a species like swordfern can be very effective. On this site in Port Orchard, we had, there was this like 50, 75, square foot area that was all sword ferns. And it was actually more like 150 feet, but there was 3 trees growing in there that had no ivy on them. There was no ivy within these sword ferns. The sword ferns were effectively keeping the English ivy at bay. So if you can have that, competing vegetation, or as you remove it, replace it with desirable vegetation, that can help you in a long way towards your goals. Scotch broom is the scourge of everyone with allergies. And I'm sure most of you know when it flowers, but generally it happens in April. Early April, so it may be best to remove it in late March. Watch for it to start flowering. You usually will see it start to happen before it really blooms. Manual control is again recommended, but that comes with a really big caveat in that I've had a lot of success pulling out Scotch broom with a weed wrench by the roots. It has a really nice job of pulling it out, the single tap stem in one big pull, but you really do have to avoid disturbing the soil if possible. Scotch broom is really good at germinating if soil is disturbed. It kind of fills that niche really well. So if you need to, like I would not dig out a Scotch broom with a shovel or the pickaxe like you would the blackberry. The Scotch broom seeds are viable. They don't know how long they're viable in the soil, but they measure it in decades because it's taken that long to figure out. If you cannot remove it out of the soil, maybe you don't have a weed wrench, or otherwise there is the slope or the site conditions are too difficult to pull it out, you should chop it down with a hatchet, a machete, loppers, whatever you need to, as close as you can to the ground, and do that repeatedly. About I'd say once a year would be effective with Scotch broom. And then replace with desirable vegetation, maybe such as ocean spray, a big, nice, good shrub that can fill that niche. Sometimes mechanical control is not effective. Some species like bamboo or knotweed are very difficult to remove manually. Bamboo has a ridiculously thick, hard root mass that you have to use a pickaxe and a lot of labor or even heavy equipment, which is not going to be very applicable to a lot of shorelines. It's difficult to reach, difficult to access. And knotweed, you can remove knotweed manually, but I really don't recommend it because a single human hair sized bit of knotweed can make a new plant. It actually likes it when you try to remove it manually. It actively causes erosion, which may be a concern if you're on a shoreline, because erosion can often help it spread further than it would. It's one of its ways of propagating itself. I don't often recommend herbicide, but there are cases where it is applicable, even though I do not like to use it. If you think your property may be a site where you need or should use an herbicide of some kind, I recommend contacting noxious weed coordinator Dana Coggin. Her contact info is on the screen. I'm gonna let this sit for a moment so you guys can write that down if you want it. She can provide technical assistance on the herbicide. She can put you in touch with a licensed applicator that is licensed in the correct way for your site. And but be patient. She's very busy. She has lots of people asking her questions. It can take about 2 weeks or so or more to get back to you. She's very busy. All right, I'm going to move on to the next slide. So finish writing that down if you are. And keeping weeds gone is more important than actually getting rid of them. Competition, as I touched on earlier, is one of the best ways to keep them at bay. Native plants will use resources, making it harder for noxious weeds to get a foothold. That is both sunlight and soil resources. Competing vegetation will definitely reduce your maintenance needs. If you if you go remove the blackberry and you're going in and doing light weeding, picking out those little blackberries, and then you have good native vegetation like those Nootka roses coming in, it can make it a lot easier because they're doing the work for you, preventing those seeds from germinating or just using the resources so they can't grow fast enough, making it so you don't have to do, theoretically, you don't have to do maintenance 2 to 4 times a year, maybe only once every other year if you get your site to that kind of establishment. Deep shade is your friend, which is a little difficult on shoreline bluffs, but if you can develop a good tree cover, I would recommend it. Most weeds, or noxious weeds, can't grow in deep shade. Blackberry can grow in deep shade, but it produces 80% less seeds, which means it's going to spread a lot less. So if you can do deep shade, keep your trees in some way, it is very helpful. And again, applying 3 to 5 inches layer of bark or mulch from any soil company or chip drop service is very helpful. In the picture on the left, this is a stream project I did in 2019. We planted a dense suite of plants, including ground cover, shrubs, and trees, to try and eventually to provide the adequate vegetation for the stream, but also to compete at multiple layers with potential weeds that could be coming back. The landowners there have been doing excellent maintenance, keeping anything that pokes its head up out of the bark. They just keep on it and pluck it every week. They're amazing, but not all of us have that kind of time on our hands. So do what you can and what is approachable for your schedule. Maintaining existing natives is very helpful. Say you have a little rose on your property, on your shoreline, and it's just surrounded by the invading hordes of Himalayan Blackberry. Our native roses are thicket forming. So if you clear the blackberry and around it, if you give it an inch, it will take a mile. So if you just give it that little bit of support, with the existing native vegetation that you have that's already established, it can do a lot for you. And it's better to keep what you have than to bring in new vegetation. And keeping your area clear, not topping your trees, not storing yard waste on your shore bluff, keeping it free of trash and debris is very helpful in keeping the plants, the good vegetation, growing. Also makes it a lot more accessible for maintenance. This picture on the right is another stream project of mine that I did in 2019. We pulled out, the previous landowner, not the ones who own it now, had put a lot of debris just down in the stream riparian area there. We found multiple old Christmas trees, any branches that presumably fell off the alders. There was even a washer and dryer down there. We pulled it all out, planted it, and the new landowners are doing a much better job at maintaining that now that they have access and space to, and the plants have space to grow. So before you start your removing vegetation, you need to make a plan. And this is where the integrated pest management is going to come back in. And this is the only other wordy slide of the presentation. So first, you need to inspect your site, your property. Where are the noxious weeds? And check for signs of erosion, because those are going to be really critical, knowing where those high risk areas are, because you're going to need to treat them differently. Either focus more on vegetation rather than removal, because you need those roots, or maybe you need to go slower in that area so you can get established desirable vegetation, over time. And you should learn what species are growing, both good and bad. You have maybe a lot of English ivy, but you have some other desirable species in there that you need to save because they're helpful. Many of you have probably owned your properties for years, and you've already observed the growth cycles, and you know what different species there are and what different species and when they flower. That's great. That's helpful. If you're new, you should maybe take some time to watch and observe what's going on, maybe over a year, and then so you know where those trouble areas are. It can better help you make a plan. When you go to implement a plan, don't take on more than you can handle. Again, it's a marathon, not a sprint. Do what you can in small chunks, whatever is approachable, something that you can do. You don't want to burn yourself out. Make it, something you can always do. Get the kids out there if it's, safe, not, a steep slope. And definitely be careful around areas of erosion. You do not want to remove too much in those areas. And after you've implemented it all, you've removed an area, you've planted it, evaluate your work. Did your strategy work? What could you do better? Can you do more next year? Can you do less? What's your schedule look like? And after you've done all that, you've implemented your plan, I want you to enjoy the result. Give yourself a pat on the back. It's hard work and it's done right and it feels good. You can enjoy your view. You're going to have, if you did install new plants, you're going to have a wide range of, depending on what you put in, native wildflowers coming in. On this site, this was a stream project that happens to be on a shoreline. We planted really densely on the edges next to the weeds. The neighbors did not want us to work on their property. They did not want to buy in, but we worked with what we could. And I am going to open it up to questions. All right.
Awesome. Okay, Jesse, I've got a couple questions coming in through the Q&A here, so I'll just start listing them off, okay? All right, so
Okay.
first I have, what are your thoughts on removing poison oak?
If it is a problem for you, if it's something that you just can't live with, I'm sure there's a way you could go about doing that. I don't have any specific advice for poison oak at this time.
All right, okay, next one. For non-shoreline slopes, can you use a high-quality landscaping fabric to cover soils if mulch is difficult to get into the site?
That's a very good question. We, on at least from a stream point of view, we use a coir fabric that's thick. It lasts up to 5 years to try and help hold in soil against erosion. That may not work so well on Shoreline Bluff. I might want to ask Jim what fabric he would recommend, if any, for that. But usually you want to pair, if you're going to use some kind of fabric like that, I would pair it with planting at the same time. Jim, do you have any thoughts on that?
Yeah. Hi, guys. There are certainly different fabrics. The coir, like the GeoCoir 700, is the little bit thicker jute mat that I think Jesse's referring to. And that can work very well. It's low cost, and it's biodegradable. Going up in quality and longevity, brings you to use of synthetics. So there's some with coconut fiber to keep moisture in, and a synthetic mesh for strength. Cost goes up a lot, and the installation works a little harder. But if it's a really critical slope stability issue and you need it to be there for years to reestablish vegetation, then that can be warranted. But like I said, it's higher cost, and then you'll have that synthetics on the slope for a very long time.
And yeah, I use a 900 weight fabric for
Okay.
coir. At least that's what we use for ours, where possible. If possible, instead of the fabric, you may want to consider native vegetations that may be able to do the same purpose, depending on how accessible the slope is and what you're able to accomplish.
Awesome. All right, thanks guys. Okay, next question. If you have ivy on a steep slope, is it best to just leave it?
That's gonna really depend on the site specifics. I do have a landowner who's got a steep slope that he's literally taking the painstaking effort of removing 3 square feet at a time and replacing with native vegetation. It can be difficult, and that is, I would definitely say that is a site-by-site situation.
Awesome. All right. Horsetails, good or bad?
Good. I know a lot of people don't like them, but they are native and they're really easy to plant around. Grasses tend to use a lot of moisture and can kill the native plants, or at least make it harder for them to establish. Horsetails do no such thing. So, I mean, if you don't like them, you don't like them, but you're never going to get rid of them.
All right. Great. Next question. Is there a place to get rid of invasive plants? Is there a noxious weed place to get rid of noxious weeds?
Depending on the weed, what it is, most of it, like for tansy and a lot of others, you can put them in a trash bag and do them through the normal waste disposal services in your, to the dump. I know Kitsap County does, like, the coordinators will do noxious weed bags. It's just a plastic bag. It's all the same. For some of them, like Himalayan Blackberry, some of the composting and soil companies will even compost those for you, which can be effective disposal.
Awesome. All right. Next we have is a list of desirable plants available through the county.
I'm not sure. I'm sure there's a list somewhere. I honestly don't know. You guys, Angie, you had a list of species, right?
Yeah, we do. So ours are shoreline specific, but we do have a list of desirable native species plants on our Shore Friendly Kitsap website. Beyond that, if you're looking for other than shoreline, we don't have that. But Yeah, so we do have shoreline specific though, so that can be found there. I'm not sure where the best place to go for otherwise would be. Do you have any ideas, Jesse?
I do. We have the collective of districts in the Pacific Puget Sound area have a website called betterground.org. We may want to put that in chat, but we are starting to put lists on there. And beyond that, I know King County has some really great lists that are targeted to different conditions such as sunny and wet, sunny and dry, slopes and otherwise. Those are very high quality lists that I do refer to sometimes myself.
Awesome, thank you. All right, next question. Is vinegar effective and safe?
That is a difficult question because it can be effective, but it depends on the species and where that water's going. So I would say it depends.
All right, next one. Tansy on shorelines a problem?
Tansy is always a problem wherever it's at. If you have tansy on a shoreline, that's pretty unique. I don't see that a lot often. Maybe more of a field setting than a slope. I guess it could happen. Tansy is tenacious one way or another.
All right, awesome. We have one more question and then we're going to start wrapping things up. Okay, so last one. Is it effective to dispose of English ivy at yard waste, or will it have the ability to germinate after decomposition?
That is a very good question. I'm not sure I have an answer to that. I know I've brought English ivy to the dump and they've taken it and it has been no issue. It does not need to be bagged, so I don't think there would be an issue there. Yeah.
Awesome. Great. Okay. I'm all out of questions. Awesome job, Jesse. Thank you so much. This was super informative. So just want to thank all our participants and speakers today. I do want to let you guys know as well, I will be sending out an email. So it'll have like a little survey. Since this is our first webinar, we kind of want to know how we did, where we can improve. So if you will take a minute or two for that, I'll send that out. In addition to that, in the email, I will include the list of links that both Jim and Jesse mentioned. So we'll have a list of links, some cool resources to check out. So make sure to be on the lookout for that. And don't forget, we have our part 2 webinar next week, February 10th, same time, 1 to 3 p.m. And that's going to be on shoreline restoration and projects. We will also have a portion for Kitsap Conservation District as well. So we'll be talking a little bit more about plants and vegetation. And from here, I'm going to hand it over to Christina before we all sign off. Thanks so much again, you guys.
Hi again. Yeah, I would just like to echo what Angie said. Thank you to the presenters, Jim and Jesse, for giving such fabulous talks. They were really engaging and interesting. I know that I learned new things, great overview and great new nuggets of information. Secondly, thank you to all you folks who attended and hung on for the 2 hours. I know that it's often hard to find time in our busy schedules, but it's really inspiring to see so many people interested in learning more about the nearshore ecosystem. And also personally, for me, it's also encouraging to think that there's really the potential for new restoration opportunities in Kitsap. So please don't hesitate to call or email me if you have any questions about the program. I'd be happy to chat more about potential projects, your specific properties, as well as the parameters of how the program works. And I will stick my information in the chat here so you can contact me directly. And so with that, thank you. And we hope to see you for part 2, and we will focus more on restoration at that time. So thanks. And we will be trying to post this presentation, so that I see that question there. That is a goal. We'll be working on that and getting it up as soon as we can.
Awesome. All right. Thanks so much again, you guys. Have a great rest of the day, and we'll see you next week. Take care.
Okay.